So example 7 then, King Kenny's number. We'll have a look at that. So in this example we're told that a CT7-9C turboprop engine delivers 1750 shaft horsepower. Okay, so this is new, we're using imperial units of horsepower at 1200 revs per minute. The prop shaft is a solid circular steel shaft with shear stress, and the shear stress is limited to 90 meganewtons per meter squared. Determine the shaft diameter. Alright, so the first thing is that 1 horsepower equates to 745.7 watts. So that's the first thing we'll do. We'll take this 1750 shaft horsepower, we'll multiply it by the 745.7 to convert it to watts, and that gives us, well, I've just rounded it off here as 1305 kilowatts. These are the standard formulae that we use in Torsion. We have RPM, so we have N value here of 1200, and we have tau as 90 meganewtons per meter squared. Okay, so I've substituted those values in. There's tau. I don't have the radius c, so I'm just saying it's the outside diameter divided by 2. I do have N, so omega is 1220 multiplied by 2 pi divided by 60. When I put that into the calculator, I get 128 radians per second. Power is torque times omega, so torque is power over omega, so torque is power over omega. So the power was 1305 kilowatts, and I'm going to divide that then by omega, which was the 128 radians per second, which we just spoke about. And when I do that, I get a torque value of 10195 newton meters. Second polar moment of area is just pi d to the power 4 over 32 because it is a solid shaft. And I'm going to take this formula, bring it down here, and just substitute in the values. So instead of the torque, I'm going to put in my torque figure of 10195 newton meters. For J, I'm going to put in pi d to the power 4 all over 32. This equation here, and this part remains unchanged. Okay, so the first thing I'm going to do is get rid of the fractions. So this side of the equation I'm going to multiply above and below the line by 32, and on this side of the equation I'm going to multiply above and below the line by 2. I'm now going to cross multiply to bring the d to the power 4 up here and bring 2 times 90 by 10 to the power 6 down here. So they've just moved. D to the power 4 divided by d is d cubed. So if I want to get d, I get the cubed root of all of these expression here. So if I bring up my calculator, it's the cubed root of, so it's 32 by 10195 all over 2 by 90 10 to the power 6 by pi. And I get 0.083, which is rounded off to 83 millimeters.